Oh.
It's going.
Yay!
We fail at life.
It took 10 people to get this camera working, but here we go. We're doing 1.7, as I was saying to the rest of you. When you solve an equation, I don't think any of you would have a hard time solving this. If that was an equal sign, you would move the 3x, move the 4, call it a day, you'd get one solution. You would get x equals one number. The difference between solving an equation and an inequality is the number of solutions that you get. So we're going to go forward and solve like normal. We're going to move the 3x just like we would if it was an equation. And you get 0 less than, what's 9 minus 3? 6x plus 4, yes? No one's confused yet? No. Subtract 4 from both sides. And you get negative 4 is less than 6x. And then you would divide by 6, but because you're dividing by a positive value, you don't flip any signs around. So you're going to get that negative 2/3 is less than x. And that is technically the answer. But if it was an equation, it would say the same thing. It would just say negative 2/3 equals x. And how many numbers actually equal negative 2/3? 1. Finite. Countable number of solutions. You get one solution. How many numbers are less than, or sorry, greater than negative 2/3 in this case? An infinite number of numbers are greater than negative 2/3. Do you see what I'm saying? That's the difference between inequalities and equations. So this is probably not the way we want this to read. It's kind of backwards. We usually put the variable first, right? So if we do that, then it would say x greater than negative 2/3. So saying that negative 2/3 is smaller than x is the same thing as saying that x is bigger than negative 2/3. So I didn't switch the symbol because I divided by negative. I just switched the symbol because I'm saying in a different direction. Instead of saying that I'm older than Kit, I could say Kit is younger than I. Right? It's the same thing, but different word that I used. So same thing here. Negative 2/3 is less than x is the same thing as saying that x is greater than negative 2/3. So you could solve, they'll ask you to do the middle number line thing. You have a 0 here, negative 2/3 is somewhere off to the left. You have an open dot because it's not an equal to, and greater than would be this direction, and yada, 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 we're all good. That is not the hard part. As I already mentioned earlier, the hard part is when you're solving non-linear inequalities. So we're not going to spend a lot of time going over linear ones, because I'm pretty confident that you already know how to solve them. You could also write this in interval notation. Do you guys remember interval notation? Does anybody remember how to write this solution in interval notation?
Oh, I do.
Yeah? How would I do that?
It was negative 2/3
Infinity. Greater than. So it starts at negative 2/3 and goes on forever. That's my interval. You never want to put a bracket on the infinity symbol. We already said that. And because there's no equal to, you're not going to put a bracket on the negative 2/3 either. So are we good with this? Now we get to the heart of the other stuff. And I will tell you right now, and I'm sometimes happy when I record because I feel like I could go back and say, see, I told you. And I'm telling you right now, you're going to watch me do this process. It's going to be long. You're going to hate it. It's not going to be fun. But if you don't do it, you don't get the points. Okay? So sometimes people give me the answer. They get lucky and they have the right answer. But I'm not going to give you all those points, and there's usually several points involved, if you just give me the answer. I want to see the entire process happen. Okay, so we're going to start with the quadratic. So this is example 3. I kind of skipped example 2 because I don't think we need to spend a lot of time on linear stuff. We want to spend time on things that are more complex. And so example 3 is a quadratic, I believe. And
We're skipping it.
we're not skipping example 3, we're skipping example 2. Whose phone is that?
Mine.
Put it away. So we have this.
Okay.
Didn't somebody say mine?
Yeah.
Okay, anyway. So, first thing you want to do, just like if it was an equation, is you want it to be set to 0. Okay? So we're going to rewrite that as negative 5x, positive 6, settle. And for a brief moment, we want it to be set to 0. So I move the 5x and the negative 6 to the other side. Right? So we're good again. Okay. So now for a brief moment, we're going to pretend that it is an equation. And when we do this, we are looking for critical numbers. We are looking for critical numbers. And critical numbers, it kind of reminds me of like when you're like in the hospital in critical condition. What does it really mean? I'm not saying you're going to die, okay? I'm just saying that what does it really mean when someone's in critical condition? They need more care, right? They need more supervision, maybe an extra nurse. They're in a special ward where their ratio of patients to nurses is a little bit, better than like 20 patients for one nurse, that kind of thing, right? They're in critical condition. They need a little bit more a careful monitoring, if you will. And the same thing is here. So these numbers that we're going to get are numbers that require some attention from us. Some special attention, okay? So we're not solving the equation right now. We're just finding the critical numbers. And to do that, you basically take this and you make it equal to 0. So for a brief moment, we're going to forget about the inequality part, and we're just looking at x squared minus 5x plus 6 equals 0. You could solve this quadratic however you choose. Complete the square, quadratic formula, factoring. I suggest that you try factoring most of the time first, and if that doesn't work, then you can go on to the quadratic formula. If you really want to be a complete the square pro, then go ahead, but completing the square will give you the same thing that the quadratic formula will give you, right? So, anywho, in this case, I think that factoring will work well. So we have x, and then we've got 2 times 3 is 6. If we make those both negative, we'll get the negative 5x that we need in the middle. And so when I factor this, I get x minus 2, x minus 3 equal to 0. And so then my critical numbers, which are the solutions to this quadratic right here, would be what? 2 and 3. Those are critical numbers. That's all they are. They tell us when this expression here, x squared minus 5x plus 6, they tell us when it equals 0. But understand that that's not what we want to know. We want to know when it's going to be negative. Right? It says less than or equal to 0. So what about all the numbers that are less than? This only tells me when it equals 0. When is it less than 0? You probably already know what a quadratic looks like. Okay? A positive parabola will look something like this. Something like that. I'm not saying that this is the exact same graph as that, but it will look something like that, right? It's supposed to be going up. If it was negative x squared, it would be going upside down, right? But the point is that what we're looking for here are the intercepts. So we have that and that. When you get your critical numbers, all you have found is those 2 points. Right? That's all you found. So prior to this point, all of these values are positive. After this point, all of these values are positive. In between these 2 points, all of your values are negative. See? So we end up with these intervals. There's like this interval, then in between the 2, and then over here. The more critical numbers you have, the more intervals you're going to get. Because as you can imagine, this graph can get more complicated if it's not a quadratic. You might end up with something like this. And then you've got interval, 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 interval. How many critical numbers? 3. So you're always going to have one extra interval than the number of critical numbers you have. Okay? So, but for now, let's continue with our problem. And how do we then figure out which portion, without graphing it, how do we figure out where it's going to be negative or where it's going to be positive? So what you do is you set up a chart. And that's the part that people don't like. So you take your critical numbers and you basically make all the intervals. You're going to start with negative infinity. So that's pretty much pretty easy because you always start with negative infinity because you go from left to right all the time. So negative infinity up to the first chronological order, okay, the first critical number, which is 2. Then you're going to go from 2 to the next critical number. And then you're going to go from that critical number to the next one if there is one, or in this case there aren't any more, all the way to positive infinity. So your first and last should always include infinity. The first should always have the negative infinity to start with, and the last should always have the positive infinity to end with. So I have 3 intervals. Okay? Then we want to pick a representative. You know what that is, right? Someone that represents a larger group of people. So this is a big group of people, like the freshman class, the sophomore class, the junior class. And then you pick one person to represent them. But that person, like the freshman representative, has to be a freshman. You can't be a senior trying to represent the freshman if you're not even the freshman. Like, that doesn't make any sense. So you have to be in this interval. And that's really important because sometimes people pick numbers that aren't in the interval, and then they wonder why they got the answer wrong. Okay? So what number is between negative infinity and 2?
1. 0.
Thank you. Yes, 1 is correct, but 0 is probably the one you want to pick. It's easier to plug in.
Okay.
Anytime you go from negative to positive, pick 0. You can't pick 0 for all of them, but pick 0 for the one that goes from positive to negative or negative to positive. So 0's in here for sure. Between 2 and 3, 2.5. You could also pick 2.7 if you really wanted to. 2.1, 2.09. But don't get crazy. You would put 2.0009. Yes?
Could you pick 2 or 3?
No.
So
Because we already know that when x is 2, it equals 0. We want to know what happens in between them, not at the endpoints. We already know at the endpoints it's 0. Okay? So then between 3 and infinity? 4. Okay, be smart. Don't pick 109 because that's here, obviously. But that's a big number to plug in.
Let's pick pi.
You could pick pi. But again, it just makes things more complicated when you pick pi. Okay? Pick easy numbers. I'm not trying to make this difficult for you. All right? The next thing you want to do is on this side, you're going to get like a little chart. So this is like your row going this way. Now we need columns. So what we're going to do is we're going to put our factors individually. There's my first one. Here's my second one. And then here's the combination. I'm just going to write both because I don't have enough space to put x minus 2 and x minus 3 together. But you have each factor separately, and then you have the combination of all the factors together at the very end. And this is not that complicated, it's just tedious. Honestly, the biggest mistake that people will make is when they see a non-linear inequality, they won't do this. They just skip it all together. And that's why I'm saying that it's not that it's hard, it's just that, you know, you have to remember that anytime you're doing an inequality that's not linear, okay, so x squared, x to the third, absolute value, anything that's not linear, you need to start doing these charts, okay? So, when you plug 0 into this factor, what is 0 minus 2?
Minus 2.
It's a negative, right? What is 0 minus 3? And then in the very end, if you have a negative times a negative, what do you get?
Positive.
So that means that in this interval, your y values will be positive. See that? So 2.5. Since 2.5 is bigger than 2, 2.5 minus 2 is going to be positive.
Positive.
And since 2.5 is less than 3, 2.5 minus 3 will be, and positive times negative will give you negative. When you plug in a 4, 4 minus 2 will give you positive, 4 minus 3 is positive, and positive times positive is positive. And that's where the bulk of your points are coming from, because you have to make sure you set up your intervals right, you get points for that. You have to make sure that you actually pick representatives, that you didn't pick a number that wasn't in the interval. That happens sometimes, those points for that. That you set up your column over here, and that you've actually filled in your chart. You could even put x minus 3 first, but you'll still get the same last or final row. Now we can go back and answer the question, which was, we know when it equals 0 at 2 and 3, but when is it less than 0? When is the expression negative? According to our chart, it's negative in this interval. And that's our answer. So our answer would be 2, 3, that interval. Or if you wrote it as a sandwich, you could say that x is less than or equal to 3, greater than or equal to 2. And my bad, I should have made these brackets because it has an equal to. So those should actually be brackets like that. Are we good? Awesome, awesome. We're gonna do another one. I think I have 2 more and then I'm gonna let you guys go. That's 4, right? This is the second example I've done.
Yeah.
And then we're gonna do 2 more and then I'm gonna let you guys start the homework. So, and it should go a little bit faster now because we kind of have the process down. So for example 4, it says x times x minus 1 squared times x minus 3, and I believe it says less than 0, like that. So the reason why this is a little bit easier for us this time is because we didn't have to factor it, right? I mean, it's already factored. So it would be crazy for us to go back and multiply everything out. When you want to find critical numbers, you want it to be factored. So at this point, what most students will forget, if there's going to be a mistake here, it's going to be with this first x. When you have an x out there by itself, people oftentimes forget it because it doesn't look like this. But this is actually x minus 0, but they don't write the minus 0. So you actually have, as far as your critical numbers this time, you're actually going to get x equals 0, 1, and 3. Right? So we understand that part, like we don't have to factor, it's already factored. But you do have 0 as a critical number. 1 is a critical number twice, right? Because it's squared. So twice you get that little guy. And then 3. So we're going to come over here and we're going to write our intervals. Remember, we always start with negative infinity to the first critical number, which is, and then we're going to go from 0 to the next critical number, and then from 1 to the next critical number, and then lastly from that to positive infinity. Then we want to pick our representatives. You can't pick 0 in this case, right, Jonathan? Because 0 is one of the critical numbers, so you can't pick 0 to be inside the interval. So you can pick negative 1. You could pick 0.5, 2, and 4.
Oh.
Yes, sir.
If it were less than or equal to, could you pick 0?
Could I pick 2?
No.
If it was less than or equal to, could I pick 0?
Yeah.
No, you still, even if it was equal to 0, it would just tell you that at that point it equals 0. You're trying to find what's happening in between the interval, not on the endpoints of the interval. Yes.
So when we do the x minus 2, the x minus 3 from the previous example, how do we do, so it'd be x,
Like how did I get this?
Yeah, like,
Those are these factors.
so then how would you
So you
do
put
this?
them separately, and then you put them together.
How would you
So
do
we're going to do that right now.
Okay.
So
You would do
x minus
x,
0, which is that?
x minus 1 squared,
Well,
x minus 3, and then all of them. What is their sum total equal? At this point, you don't have to write them all out, but understand that you're using all 3 of them at the same time.
What?
Thank you. I mean, you're welcome. Bless you. Something, I don't know. Something happened over there. I wasn't quite sure what happened. But okay. So the first row is going to be really easy because it's just asking you for the sign of x. So
Yeah.
that's obviously negative. That's a positive. That's a positive. That's a positive. Now x minus 1 squared. If you have negative, well, anything squared is going to be, but, okay, so you have negative 1 minus 1 be negative 2, but negative 2 squared would be positive, right? These are all going to be positive. Because when you square it, it's going to be positive. And the negative 1 minus 3 is going to give you a negative. 0.5 is smaller than negative 3, so you're going to have a negative. 2 is also smaller than 3, so you're still going to have a negative. And then 4 is bigger than 3, so you're going to have a positive. These two negatives here will join to be a positive and a positive, so you'll end up with a positive. These two positives will get thrown off by this one negative here, so you'll get negative there. Same will happen here, and then these will all be positive. And then for our final answer, they wanted less than 0, right? So they want negative. So it's going to be these two here. But just because they're next to each other doesn't mean that you can say from 0 to 3. Right? You can't do that because at 1, it's equal to 0. And it doesn't have an equal sign here. Right? If it had an equal sign, then you could say from 0 to 3. But you can't. So you're going to basically combine from 0 to 1 and then union that with 1 to 3. And I have parentheses on everything because nothing is, there's no equal to, so everything's going to be open, 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 open. So this guy is from 0 to 1, this guy is from 1 to 3, but you don't want to include the 1, so you have to write it like this.
Is that a union?
Yes. It means this or that. Jess? So on a number line, it would kind of look like this. And you would have, you know, here's your 0, 1, 2, 3, I guess. And it would be open on the 0, open on the 1, like that. And it would be everything in between. But these would remain open. So you'd have this big old hole right here in the middle on the number line. Okay, so we'll do one more. And this one's actually going to have a quotient in it, so a little bit deeper around. I will walk you through it, and you will be like, ooh, so easy.
I think it's better than the first one.
Okay, can I switch the... Ashley, can you check the time on the camera? I just don't want it to turn off on me.
Well, that's because it's
22.
so
How much?
From
22
Okay.
minutes.
So we have 8 minutes to do this, people.
Like,
Let's see if it works.
since they're both negative, you can either do this one or
1
this
plus
one.
x over 1 minus x greater than or equal to 1. Okay? So the first thing we have to do, which probably wouldn't seem like you would have to do, but I need to tell you that you have to do this. Like the quadratic earlier, you want it to be set to 0. And it's not. So the first thing we want to do is move that 1 over. Like that. And then basically what you want to do is to combine the left-hand side and make it one fraction. Right now you've got like a fraction and an integer. You want it to be one big fraction. So this guy needs a common denominator, right? So that would mean 1 plus x over 1 minus x, and since the only denominator here is 1 minus x, it would be minus. Does that make sense? It divided by itself would be 1. Right? Now I can combine the top into one fraction. So I'd have 1 plus x minus, and be really careful that this is a negative, so you want to distribute it to both. So I'm going to go ahead and use parentheses so I don't forget to do that over my common denominator. So now when I simplify this, it's going to be 1 minus 1, which is 0, right?
0.
And then x minus negative x, which is actually x plus x. So 2x over 1 minus x greater than or equal to 0. So all we've done so far is simplify the original problem. Now we need to find critical numbers. And for a quotient like this, where you have like a division happening in a rational expression, if you will, for critical numbers, you need to do the top and the bottom equal to 0. So for critical numbers in this case, critical numbers, we're going to do the top, which is 2x equals 0, and we'll do the bottom, 1 minus x equals 0. So in this case, I'm going to get x equal to 0. And over here, if I add the x over, x will equal 1. Those are my two critical numbers, 0 and 1. So we get our chart going. We go from negative infinity to 0, and then from 0 to 1, and from 1 to positive infinity, right? We pick a representative. So here we'll do negative 1, 0.5, maybe a 2 over here. And then we're going to put both pieces of our rational expression, the 2x, which is the top, and the 1 minus x, the bottom, and then both combined. So 2 times negative 1 will give us a negative 2. A positive times a positive will be a positive. So those two will be positive. Here we're going to get, be careful here, okay, because you're plugging in a negative. So it's 1 minus negative 1. It's actually 1 plus 1, so that's going to be a positive. 1 minus 0.5 is still going to be a positive. But 1 minus 2, since 2 is bigger than 1, will actually be negative. And when you combine them together, you have a negative and a positive will be a negative. Positive, positive will be positive. Positive, negative will be negative. And they want it to be greater than or equal to 0. So that'd be positive. That would be this interval right here.
So how do you do the last one?
This is 1 minus negative 1, which is 1 plus 1, so positive 2.
No, the both.
Because a negative divided by a positive is a negative. So when I say both, I mean the combination of both of them together. And then positive divided by positive is still positive.
Oh, okay.
And positive divided by negative is negative. Okay, so our answer, this is where it kind of gets interesting. It's supposed to be 0, 1, but we can't, it has an equal to. So technically, we're supposed to be able to do this, right? Because it's an equal to. However, the bottom cannot equal 0, because if it does, you would get division by 0. So I threw an extra little curveball at you right there. So don't be crazy at the very end. Whenever you have a rational expression, double check at the very end that the numbers are not critical numbers from the bottom. See, the 0 is a critical number from the top. Totally okay. The 0 can be on top. The 1 is the critical number from the bottom. Can't have the 1 on the bottom because that would be division by 0. So I can leave the bracket on the 0, but I have to make this bracket a parenthesis. Not because of the chart here, but because I can't divide by 0. So my final answer would actually be 0, 1 with the bracket on the 0 and the parenthesis that's open on the 1. And that is how you do that. So if someone can turn that little guy off, I will give you the rest of the time to do some homework. And then mañana we'll see how you did. And go forward from there. Just push the red button. Right there, yep.